All right. So here I'm going to share with you how I was able to solve the buffer overflow homework assignment. So the main goal of this assignment was to call the TBD function that isn't called anywhere in the main using a buffer overflow. And we do this by replacing the return address of f with TBD. So rather than coming back to the main function when f is done executing, we'll go into TBD. Now what makes this possible is these two lines right here. So we first have our unbounded command line argument, argv1, and we copy that into buffer, which is a fixed length of 6. Now, since there's no bounds checking, we can put as much into buffer as we want, and if it goes over 6 bytes, which is the size of a char data type, it will bleed over into other things on the stack. So let's get into how I did this. So to compile the program, I used this command here. So I included the -g flag so we could use the debugger, and then this fno stack protector flag. So what this does is this disables stack smashing warnings, which would notice that we're going over the buffer and kill the program, which we can't have if we want to do this correctly. And then, yeah, I also just named the executable buffer with the -o flag. So how on earth do we find the return address of f? So the way I figured out where it would be is by thinking of where the return address of f will be on the stack once we get into the f function. So we know that it's going to be at the bottom, which means it needs to be pushed on before our old base pointer or our function parameters and then our local variable buffer here. So how I thought I could maybe find it is if I check the contents of the stack before we step into the f function, right at line 21 here, taking a look at the stack and seeing what's on top. Once we step into f, the return address should be on top of whatever, or should be pushed on top of whatever was on top of the stack here in main. So let's get this started. First get our GDB going here. Okay, so now we will set a breakpoint at line 21, right before the f function is called. And to kind of get a feel of where the contents of buffer would be on the stack in relation to the return address of f, I just initially ran the program with the safe buffer length of 6 characters, which we will use a. Okay, so now we are at the point in the main function right before we go to f. So now let's check the contents of the stack. And to do that, we first need to print the address. So this is the address of the stack, and now we want to take a peek at its contents. So we will print out the first 48 bytes of it onto the screen. Okay, so right before we step into f, this C8 address here is what is on top of the stack. So if my thinking is correct, once we step into f and check the contents after S has been copied into buffer, we should see the return address of f right above this address. So let's step into f, get buffer into the stack, and let's take a look at the stack again. But this time, we need a little bit more range, so we're going to print the first 64 bytes. Okay, so now we need to find where the C8 address is. Taking a look down here, we found it right here. So if my thinking is correct, this address right here should be the return address. But now we need to find out where our A's are at so we can calculate how many A's over the buffer we need to go in order to get here. So we look here, here are A's, and I know this because the ASCII byte value of capital A is 41. So it is right above this address here, and then here's the return address. So I know that the old base pointer is on top of the return address, so that must be what this is. So now we need to add 8 more A's to get past the old base pointer before we arrive at our return address. But also to make this work, we need to figure out what the address of TBD is, and to do that, we use the nifty info address command on function TBD. Okay, so now we know that the address of TBD is this. So back over to my little command cheat sheet over here. We can use this command to set the arguments for when we rerun the program. We can use Perl to print 14 A's. So this time we will fill up buffer here, and then we will bleed into our old base pointer by 8 bytes until we get to the return address where we can insert the address of TBD. Now you might say, why does this look different, or why does this look backwards than the address that was printed here? Now the reason for that is because addresses on the stack are in little endian format, so we need to start with the least significant byte. So now let's reset our arguments. Okay, and we will restart the program. Okay, so now we again, after restarting the program, we are back at line 21 before F is called. So let's take a look at the stack again. So again, the top of the stack is now this B8 address. So if we did this right, we will see this address right on top after we step right on top of this address when we step into F. And when we completely go through F, we should go into TBD. So step into F, insert our payload into the stack. Let's take another peek. Okay, so we will again look for our B8. Here it is. We see the address of TBD right on top. So now, when we continue, if I did this right, rather than getting our not quite right message here, we should see the message printed in TBD. And there we go. We have the message from TBD, and that is how I was able to solve the buffer overflow.